Hello everyone. In this video I'm going to go over basic rules about graphing functions. So uh, the first thing that I can say in graphing is just graphing by plotting points. So the graph of a function is simply the set of all points of the form a comma f of a. So whenever you graph a function, you simply plug in the values from the domain. Here a is in the domain. A is in domain of f. And then you plot that point, and that the point, the coordinate, the ordered pair second coordinate represents the value of the function. So let me just show you that on an example. Now look at this example, first basic example of power function. Say f of x equals x squared. So you know this function, you can plug in any value that you like for x, but we'll do a small table. That's x, and then second coordinate is y. That is represented by x squared. See, that's sometimes we just have the notation y equals f of x, which clearly shows that the y coordinate represents the values of the function. So x values, they're independent values. You can choose whichever you like. Like for example, I can choose 0. If I choose -1 plus 1, it will not change because I'm squaring it. So it's going to be 0 here, 1, 1. If I plug in -2, +2, it's going to be same, 4, 4. So now if you want to graph this one on the coordinate plane, xy coordinate plane, we have the point 0, 0 from the first row. We have here 1, which comes from 1, and then also from -1. See, like these 2 points, this one is 1, 1, and this point is simply -1, 1. See, that's like the second and the third rows. And then we have 2 here, which goes with 2, 2, 3, maybe here 4. So that point is the second point. Of course, like for -2, this is like -1. For -2, we have the same y coordinate, which is simply 4. This point. So which is -2, 4, and this is 2, 4. So now we plot some points, and then we'll simply join those points in here. That will make like a parabola opening up like that. This is how you do it by plotting points. So this is the graph of y equals x squared, or in other words, it's f of x equals x squared. So this is one example. Let's do another example here in which you have some sort of restriction. Now look at the second example. Let's say this is y equals square root of x. Now this time, as you can see, x needs to be greater than or equal 0 because it's under the square root. You cannot plug in negative values. Just to make it simple, here's x, here's y equals square root of x. I mean, you can really check that. It's not a hard task, but you can use like perfect squares. For example, if it's 0, then square root of 0 will be 0. If it's 1, square root of 1 will be 1. If it's, let's say, 4, square root of 4 will be 2. Like, you can plug in 2. Square root of 2 will be approximately, I think, like 1.4. So like we got some points in here, and let's graph this. So the x values are only taken from the right side of the x-axis. So this is the x-axis, this is the y-axis. So it is starting at 0, and then at 1 its value is 1, height is 1. So this point is like 1, 1. And at 2 it's 1.4, but at 4, so 2, 3, 4 here, at 4 the value is 2. So this is like, this point is 2, 4, 2. Sorry, x is the 4 and y is 2. And here at 2, it's like 1. This is 1, this is 2, so it's somewhere here like 1.4. This is at 2. So this point is actually 2 comma square root of 2, you know, approximately 1.4. If you graph it, it will look like this. So these are two basic examples in which you can do this graphing by plotting. So we will do more different ones. So let's solve one by using a graphing calculator. So like using a graphing calculator, how can we solve this problem? Let's say we want to graph f of x equals x to the third minus 8x squared. So so I'm going to be using a TI-8384 for this graphing. Now take a look at this. You want to graph, but you have to write down the function y equals, now I'll put x, here's a variable x, then I need to cube it, and then minus, I have 8 times x, here's a square button. So I want to graph this function. If I hit graph, you will see that it graphs, but it doesn't show the actual graph. It's not that clear. You have to check the window size. I mean, one way is you can go to zoom and you can say simply thing that needs to be, you can do like zoom in, zoom out, or you can do simply zoom box. Let's just check that one. It will simply I'm sorry, not that one at the bottom. It is zoom fit number 0. You may hit this one and that will simply fit your graph into a certain interval. But the best way is like you can go to window and you can choose the window size. Like for example, you can make it from let's say -10 to 10. Yes, but for y we need something bigger. Like if you look at the graph, maybe like we can do that one a little bit smaller. Maybe like put that -100 and then delete that one and then put like +100. So that will maybe put the graph into a better shape. So like in this case we can see the graph better. Or you may just move x to maybe like, let's say -5 maybe. That will change this again into a better format. You can look at the graph, see that shows the graph better. So this is just the way to graph it by using a TI-8384. As you see, you can just zoom fit that one, that works. You can zoom in, or you can use the window size. You can change the size of the window, and that's gonna put the graph into a more clear form. So that's how you do it on a TI-8384, and you can do this all the time, but you need maybe like an online or handheld calculator. Now the next one that I'm going to talk about is maybe graphing like a piecewise function. Like what if you have something like this form? Let's say f of x equals, on one side it's just x squared. Let's say if x is less than or equal 1, and on the other side it's like maybe 3x plus 2 if x is greater than 1. Now you know the graph of x squared, you know, like its graph looks like this. It's like I have 0 0, I have here like 1 1, here I have -1 1, and it just opens up. It's like a parabola. We call it a parabola. It opens up like that. Now this one is a line, and guys, you can draw this easily at once in this form. Now do like a table, but 3x plus 2 only works with values greater than 1. So if it's 1, if you do the table for this one, for that one, like x and then y equals 3x plus 2. Now if you plug in 1, you will get 5. 1, 2, 3, 4, 5. Like we need 6, and then we will need 7 maybe. Now at 5, 1, 2, 3, 4, 5, this is an open circle because it's not included. This is when you plug in 1. If you plug in 1, I got 5, but that's like an open circle. If I plug in 2, let's just go a little bit up. If I plug in 2, that will be 3 times 2, 6 plus 2, it's 8. So 1, 2, 3, 4, 5, 6, 7, I have to go more. Maybe here like 8. At 2, it's going to be 8. And that's included. And the graph of that portion will look like this. It's a line. And this side is open. Okay? The other side, though, the other side, which is x squared, at 1, it is 1. At 1, it's included. So I need to just put like a closed circle here. At 0, it's 0. At -1, it's 1, right? I know that. It's x squared. This is 0. This is 1, 1. This is -1, comma 1. And that portion of the graph will look like this. So that's the piecewise function. So it comes up to 1, including 1. You use the function y equals x squared, the green one. The green one, you use y equals x squared here. And then after 1, it says use the line, which is simply y equals 3x plus 2. This is how you graph the piecewise functions. And this is an open circle because 1 is not included on the line. So it's included on the parabola. So I hope this example is clear. I'll move to another example. So before I move to another example, I just want to say something like a definition here. Folks, we say that f is not continuous. The word continuous. Because there's a hole. There's a jump here. Sorry, there's a hole, so there's a jump here. Not continuous at x equals 1. Because there's a jump. There's like a jump in there. It's like a word that we use, not being continuous. Continuous means it's like you never have any kind of jumps or any breaks at that point. So it's continuous everywhere, but not at 1, because at 1 we have a jump. So let's go with the last part at which we have the vertical line test. Folks, vertical line test says any vertical line intersects with a graph of a function at most once. Like for example, look at this graph. This is a function. This is a function. Why? Because if you draw vertical lines, it intersects only once. See that? But now look at this. This is not a function. Look at this graph. This is not a function. I mean, you can draw the coordinate plane, but this is not a function. If you look at this, it intersects twice. So this is not a function. So the vertical line test says if you have the graph of a function, the number of intersections should be once. Now, I mean, there's a way to see this algebraically as well. When the graph is given, you can easily check that. It's not really that bad. Like, for example, I may put these here if you like. Just check that. Let me just put this here. Maybe that could be helpful. Look at these. These are, for example, this one is not a function. This one is a function. This one is a function, but this one is not a function. So this one is not a function. Okay, this one is not a function. This one is, yes, a function, and that one is a function. Now there's a nice way to do this algebraically. It's really an easy way to, I mean, just check that example. There's a nice way to do this algebraically. I mean, whenever you can solve an equation uniquely for y, then that represents a function. Like for example, look at this example. This is y minus x squared equals 2. Now, solve it for y. You will just move that x squared to the right side, so we have y equals x squared plus 2. This is like unique. You don't have any kind of like multiple solutions for y. So that represents a function. So yes, this represents a function. And you can take a look at this graph. The graph will look like this, folks. starts at 2, and it like opens up a parabola. So it passes the vertical line test. This is a function. But look at this example. It's x squared plus y squared equals 4. Now let's solve it for y. And see what happens. If you solve it for y, you get y squared equals 4 minus x squared. I can move that x squared to this side as negative x squared. And if I solve it, I got y equals minus plus square root of 4 minus x squared. Wow, this solution, as you see, you got two solutions. Two solutions means it's not unique. So you don't have a unique solution. So that means this equation does not represent a function. This equation does not represent a function. And if you graph this one, you can check that one. That's like a circle with radius 2, centered at the origin. So I'll try my best to draw the circle. So this circle, if you look at the circle, it fails the vertical line test. If I draw a vertical line, it intersects twice. So this does not represent a function. So in this video, we went through the basics of functions. I hope you liked this video. Thanks for watching. Bye.